Hello guys, this is a step-by-step solution to paper 1-3 of the May June 2020 MF paper for IGCSE. So let's get started. Question 1. Find the range of f and of g, and you're given the equations for fx and gx. So for this question, you need to know how the graph looks like to find the range. For fx, it's an exponential graph, so it will have this shape. Okay, so this is how a normal exponential graph looks like. I'll just write it. This is y equals to ex, and the y-intercept will be 1. And then the line of asymptote, which is where the graph never crosses, will be y is equal to 0. So now for fx, you have to shift this graph up by 3 because it's positive. So the y-intercept will be 4 for 3 plus ex. So it will actually be like this. And then the line of asymptote will also move up by 3. So from y is equal to 0, we add 3, which will be y is equal to 3 as the line of asymptote. So the range refers to all the y values, so range of f will be f is larger than 3. Okay, now for g, we know that it's a straight line crossing minus 5, which is the y-intercept. And the range for this is that g is any real value because the domain is x is any real value, so the y values can be any real value as well. So we can just write g is an element of any real value. Then this is range of g. Part B, find the exact solution of f inverse is equal to the differentiation of g. Okay, so remember that this sign here is differentiation, and this is inverse. Okay, so to find the inverse of fx, we write the equation first, y is equals to 3 plus ex, and then we rearrange to make x the subject. Inverse of e to the power of x is ln. Okay, now that x is the subject, we switch x and y around. So the inverse of f is ln x minus 3. And differentiation of g is 9. So you equate these two equations. And now you have the exact solution for x. And the question wants exact. So, yep. Part C. Find the solution of g squared x equal to 112. Okay, so g squared x is equal to ggx. And ggx, you just, because gx is equal to 9x minus 5, you just sub 9x minus 5 into 9x minus 5 again. So it will be like this. So x is equal to 2. Question 2. Given that this equation, find the value of xy. So we need to know the laws of logarithms for this question. And also we need to change the log base because this is base 4 and the other one is base 2. So we can change the log base 4 to log base 2 to make it easier. Okay, so we write log base 2, and because base 2 is the base that we want to change to, and then this one we will write this part of the log, and then once again log base 2, and then now we write this part. And then we can just simplify. 4 is equal to 2 squared, and then we can bring the 2 forward, and this will be over 2 because log base 2 is equal to 1, so it's 2 times 1. So we can write this as half log 2y. And now we put this back into the equation. 2 times half log 2y, so it would just be log 2y equal to 8. And then we make the left side of the expression only have one term. So we can combine this using laws of log. So xy is equal to 256. Okay, part B. Using the substitution or otherwise solve this equation. Okay, so the hard part for this question is the +1 in the powers, but you can just separate them using index laws. So let's do each of them separately first, and then we can combine afterwards. Okay, so for the first one, we can separate the +1 and the 2x. So it will be 2 multiplied 2 to the power of 2x. And then since we want to achieve this form, which is 2 to the power of x, we can take the 2 out like that. So it will be 2y squared. And then the second part, 2x plus 1. Once again, we separate the x and 1. And this is 2y. And now we can put this back into the equation. 2y squared minus 2y minus y plus 1 is equal to 0. Okay, now we can just solve for y. Okay, now that we have the y values, solve for x. And we know that y is equal to 2 to the power of x. So we can just equate them. Okay, so we know that anything to the power of 0 will be 1. So obviously this has to be power of 0. And then 2 to the power of minus 1 is 1 over 2. So that's why x is equal to minus 1. Question 3. At time ts, a particle traveling in a straight line has acceleration of this. When t is equal to 0, the particle is 4 meters from a fixed point O and is traveling with velocity 8 meters per second away from the origin. Part A. Find the velocity of the particle at time t. Okay, since we have the equation for acceleration, we can integrate it to find the velocity equation. When we integrate, we have to add 1 to the power, so this would be half. And then we divide by the power multiplied by the differentiation of the equation inside the bracket. So if you differentiate to t plus 1, it will be 2. And then remember to add the constant. Okay, a half times 2 is 1, so we can just leave it like this. And then now we have to find the constant so that we can find the velocity of this particle. And we know that when t is equal to 0, we can equate the equation to 8 because the question states that when t is 0, the particle is traveling with velocity of 8. So we sub 0 into t, and this is equal to 8. So c is 7, and we can just rewrite the velocity equation. Part B, find the displacement of the particle from the origin at time t. Okay, so to find the displacement equation, we integrate the velocity equation. Okay, same thing. You just add 1 to the power and then divide by the power and the differentiation of the value inside. And then 7 will become 70 after you integrate. Add the constant. Okay, to find a constant, we can sub t equal to 0 and make that this equation equal to 4, because the question states that when t is equal to 0, the particle is 4 meters from the fixed point. So let's just sub it in. Okay, we have the constant, so we can rewrite the equation. And this is the final answer. Part 4, write 2x squared plus 3x minus 4 in this form, where a, b, and c are constants. Okay, so we need to complete the square. But before we do that, we need to factorize 2 out, because we can't have any coefficient in front of x squared. Okay, now we can complete the square. Okay, so this should be the final answer. Part B, write down the coordinates of the stationary point on this curve. Okay, so we can use our answer in part A to help us answer this question. From the completing the square form, we can already tell the stationary point, which is this part is the x coordinate and this is the y coordinate. But for the x coordinate, you have to switch the sign around. So the stationary point would be minus 3 over 4 and minus 41 over 8. Part C. On the axis below, sketch the graph showing the exact values of the intercepts of the curve with the coordinate axis. Okay, to sketch this quadratic graph, we can first find the x-intercepts. So you can use the equation function in your calculator or use the quadratic equation to help find the x-intercepts. And then after that, you should be getting 0.85 or minus 2.35 as the x-intercept. Okay, so I'm just going to put it on this graph. And the y-intercept for the original quadratic graph is minus 4 without the absolute sign, but because of the absolute value sign, the entire graph has to be above the x-axis, so the y-intercept will now be 4. And now we can just draw the quadratic graph and reflect the part below the x-axis up to make it above the x-axis. So it should look around like this. Okay, part D, find the value of k for which this equal to k has exactly 3 values of x. For there to be exactly 3 values of x, it must be at this point, which is the stationary point of the curve. And from part B, we know that this point is minus 3 over 4, 41, and 41 over 8. And it's not negative because it's above the x-axis as it has been reflected, so k has to be equal to 41 over 8. Okay, question 5. We are given this equation of px, and px has a remainder of 11 when divided by x minus 3, and a remainder of minus 21 when divided by x plus 1. Find qx, a quadratic factor with numeral coefficients. Okay, so for this question, we can form two equations using the information given. Because px has a remainder of 11 when divided by x minus 3, we know that when x is equal to 3, px is equal to 11. So we can sub this into the equation. And we can rearrange this. And then the second equation we can form is using the fact that px has the remainder of minus 21 when divided by x plus 1. So this is when x is equal to minus 1. And we can just sub this in again. And this is equal to minus 21. Okay, now we have two equations. We can do simultaneous equation. So I'm gonna make this equal to a, and then I'll equate both equations. Okay, we have the value for b, so we just sub this in to find a, which is equal to minus 23. Okay, now we can rewrite px. Okay, the question wants us to find qx, and qx is multiplied by x minus 2. So we have to divide this equation by x minus 2 to find qx. Okay, we have to minus. And the remainder will be 0, so we have qx, and this is obviously a quadratic, and the question states that it's a quadratic factor, so it should be correct. Part B, solve px equal to 0. Okay, so let's just rewrite px. So x minus 2 equals to 0, x is equal to 2, and then we can use the quadratic formula for this. Or you can just factorize, and you should be getting this x value. Question 6a. Find the unit vector in the direction 5 minus 12. Okay, so we need to find the magnitude of this vector. Let's just do that first. And because the magnitude is 13 and unit vector must always be equal to 1, we can divide the x and y component of this vector by 13. So we can write the unit vector as 1 over 13, 5 minus 12. Part B, given that this, find the value of each of the constant k and r. So we can form two equations using the top and bottom values. 4 minus 2k is equal to minus 10r, and 1 plus 3k is equal to 5r. And now it's just simultaneous equation. Let's rearrange to get r, and then we can sub r into this equation. So r is equal to minus 0.7 and k is equal to minus 1.5. Part C. Relative to an origin, the points A, B, and C have position vectors as such, respectively. Find A, B in terms of P and Q. Okay, so I'm just gonna write this. For part I, we can take OB minus OA, 3Q minus P, and minus P. Part 2, find AC in terms of P and Q. Okay, so AC is equal to OC minus OA. So 9Q minus 5P minus P. So 9Q minus 6P. Part 3, explain why A, B, and C all lie in a straight line. So to explain this, we can rewrite AC by taking out 3 as a factor. And this will be multiplied by 3Q minus 2P, which is AB. So it's equal to 3AB. So this means that AC is actually AB multiplied by a constant, which is 3. And because AC and AB have a common point A with the same direction vector, we know that ABC must lie in a straight line. So you can explain this. Common point of A. Part 4, find the ratio AB and BC. Okay, so we already have AB from part 1. We just need to find BC. And BC is OC minus OB. Okay, so we can find the ratio now. The ratio will be 1 to 2 when you take 2 out as a factor for BC. So this is the final answer. Okay, question 7. The diagram shows an isosceles triangle OAB such that OA is equal to OB, which is equal to 12 cm, and angle AOB is equal to theta radians. Points C and D lie on OA and OB respectively such that CD is an arc of the circle. Center O, radius 10 cm. The area of sector OCD, which is the pizza, is equal to 35 cm squared. Show that theta is equal to 0.7. So we can use the area of the triangle, half theta r squared, to prove that theta is equal to 0.7. Because we have this area of sector. The r will be 10 because it's the radius of the circle. And this is equal to 35. So if you rearrange, theta will be 0.7. Okay, part B, find the perimeter of the shaded region. So we know that this is an isosceles triangle, so DB must be equal to CA, and DB will be 2 cm. Because the entire side of the triangle is 12, but the radius of the circle is only 10, so 12 minus 10 is equal to 2. And then to find AB, we can use the cosine formula because we have theta. So just use the cosine formula. We have AB, we have BD, we have AC. We just need to find CD. And CD is the arc length of the circle. So the formula for arc length is r theta. R is 10, theta is 0.7. So the arc is 7 cm. So now we can just find the perimeter by adding everything up. Okay, so this will be equal to 19.2. To make it clearer, 8.2 is AB, and this one is AC and BD, and 7 is CD. Okay. Part C, find the area of the shaded region. Okay, so we can first find the area of the entire triangle, and then subtract the area of the sector, which is already given in the question, and it's 35. So area of triangle, use half AB sine C. And both of the side of the triangle is 12. And then C is 0.7. And this is minus 35. So it should give 11.4 cm squared. Question 8. An Arithmetic progression has a first term of 7 and a common difference of 0.4. Find the least number of terms so that the sum of the progression is greater than 300. So straight away we know that a is equal to 7 because a is the first term of any arithmetic progression and d is 0.4 and d is it stands for a common difference. Now we just need to use the formula for sum of an arithmetic progression, which is n over 2 2a plus n minus 1 d. Okay, we can solve a equals to 7 and d equals to 0.4 to this formula to find n. And then this equation has to be greater than 300. This is a quadratic. Just use the quadratic equation and n should be equal to 25.29. And we can round this up to get 26. So n will be 26. And 26 will be the least number of terms so that the sum of progression is greater than 300. And the reason we round up is because if n is equal to 25.29, it will give us a sum of 300, but n equal to 26 will be the first whole number term to give a sum larger than 300. And remember that n can only be a whole number, so that's why it's 26. And if we get n equal to 25, it'll be a sum less than 300. Okay, so for part B, the sum of the first two terms of a geometric progression is 9, and its sum to infinity is 36. Given that the terms of this progression are positive, find the common ratio. Firstly, we can use the Hampton formula for geometric progression. It's AR minus 1 for the first term. And 1 is equal to a because the power will be 0. And then anything to the power of 0 is 1, so it's just a. And then second term. Okay, it would be AR because when n is equal to 2, the power will be 1. So r to the power of 1. From the question, we know that the sum of the first two terms is 9. So we can form an equation here. A plus AR is equal to 9. And then sum to infinity is 36. So the equation for sum to infinity is a1 minus r. So we know a1 minus r is equal to 36. This is our second equation. I'm just going to rearrange. both of the equations. So okay, I have rearranged both equations to make A the subject. Now I can equate them. Okay, so R is only the positive value of root 3 over 2. It can't be the negative because a negative ratio will give negative terms in this progression, but the question says that it only wants that the progression is only positive. So R equal to minus root 3 over 2 is rejected. Okay, question 9. The diagram shows part of the curve xy equal to 2 intersecting the straight line y equals to 5x minus 3 at the point A. The straight line meets the x-axis at point B. The point C lies on the x-axis, and point D lies on the curve such that CD has an equation x equal to 3. Find the exact area of the shaded region, giving your answer in this form where P and Q are constants. Firstly, we need to find the coordinates of point A, B, and C. So for A, it's where the curve and the line intersect, so we can equate both of them. So 2x equal to 5x minus 3. So we have two values for x, but x can only be 1 because A is in this positive quadrant. So it can't be minus 2 over 5. Okay, so this will be 1. Now we can find B. And B is where the straight line intersects the x-axis. So the y-coordinate must be 0. So 0 equal to 5x minus 3. So x is 3 over 5. And this is here. For C, we know that CD is a vertical straight line. So the x-coordinate of C must also be 3. So here is 3. Okay, now we have all the x-coordinate. We can start to integrate the graph because integration will give us the area between the graph and the x-axis. And since we're finding the area of the shaded region, we can split the graph into 2 sections. And I've already kind of splitted it with this dotted line. You can split it into this triangle and this other section here. And for the triangle section, we can integrate the straight line, which is y equals to 5x minus 3. We can integrate using the values 1 and 3 over 5. And for the other section, we can integrate the curve, which is 2 over x, and we can use the values 3, 1. Okay, so after that, we can just add the area of both of these sections. Okay, so we can start with the triangle first. We are integrating the line. Add 1 to the power, and then you divide, and then now you can just stop 1 and 3 over 5 into this equation. Okay, so this area of the triangle. Now for the other section, we are using 3 and 1, and we are integrating the curve, which is 2 over x. Okay, so integration of this will give us 2 ln x, 3 over 1. And then sub that in 2 ln 1. So 2 ln 1 will give us 0. We can rewrite this as ln 9. Okay, the total area will be 2 over 5 plus ln 9. And this is also written in the form that the question wants. Question 10a. Given that this equation shows that the differentiation is this. Okay, so we can use the product rule to differentiate because the equation has 2 terms multiplied by each other. So the first term is x, second term is x plus 2 square root. We can just change this to 1 over 2. And then differentiate this. We can use the power rule. So multiply the power by the coefficient, which is 1. So a half times x plus 2, and then minus 1 from the power. So it'll be minus a half. Okay, now we can use the product rule equation. One times x plus 2 to the power of half, and then a half x times this. And now we just need to write this in this form that the question wants. So we can change the power of a half into the root. And this will be a fraction actually because of the negative. Wait, actually, I will change this. It will be x Okay, now the denominator is 2 root x plus 2. I can also change this. I can make the denominator the same. Okay, so root x plus 2 times 2 times root x plus 2. it will be 2x plus 2 plus x. So 2x plus 4 plus x is 3x plus 4 to root x plus 2. So this is the final answer. Part B. Find the exact coordinates of the stationary point of the curve. Okay, so to find the stationary point, you need to know that at the stationary point dy dx is equal to 0. And we already have dy dx in part A of the question. So I'm just going to rewrite it. And equate this equation to 0 to find the x coordinate. And I multiplied the denominator by 0, so now it's just the numerator equal to 0. And now that we have the x coordinate for the stationary point, we have to sub this back into the original equation to find the y coordinate. So the stationary point will be this. Okay, part C. Determine the nature of this stationary point. Okay, we can use the second derivative by differentiating the first derivative. So, so we can use quotient rule. So we can use quotient rule to differentiate dy dx. Okay, so formula for quotient rule. And since we already have all these values, we can just sub it in. We have the equation for d squared y dx squared. And now we want to determine the nature of the stationary point that we found in B. So we just need to sub the x coordinate into this equation. So when x is equal to minus 4 over 3, d squared y dx squared should be 3 root 6 over 4 if you just type the whole thing into the calculator. Okay, so the second derivative is larger than 0, so this means that the stationary point minus 4 over 3 and minus 4 over 9, 6. This means that it's the minimum point. Okay, so that's it for this paper. Thank you for watching, and do comment if you have any questions.